Okay, continuing on from, we're still on packet 6, number 22. So the base of the solid region enclosed by ellipse. Okay, so we have the ellipse at 4x squared plus y squared equals to 1. If you forgot, you could actually rewrite this as x squared over 1 over 4, right? Plus y squared equals to 1. And then this would be, this is like your a squared if you remember the formula, but you don't really need to know the formula. But basically, like if I'm going to draw the ellipse, it'll look something like this. And this would be going through like, what, 1/2 and negative 1/2, and right here would be 1 and 1. Okay, if you try to visualize what the graph looks like, that's it. And so this is the base of the solid region. So we have cross sections going. I'm going to color this region. This is my base. Now cross sections are going to be semicircles perpendicular to the x-axis. So I'm going to draw one, right? Cross sections are semicircles. So if I pull that out, you're going to get a semicircle like this. Now area of a semicircle is going to be 1/2 pi r squared, right? Now this spans, this right here spans a distance from all the way from this point to all the way from this point. Now there's two parts of this ellipse, right? If I actually solved for y in this equation here, right, you're going to get y equals to plus or minus square root of 1 minus, I'm going to keep that 4 on top, 4x squared. So in the top part right here, you're going to get a positive square root of 1 minus 4x squared, and on the bottom right part right here, you'll get a negative 1 minus 4x squared. But that's actually not that bad. Let me go ahead and write this as a definite integral first, right? If I'm cutting it like perpendicular to the x-axis, right? This is going to be a dx problem, right? And so I have integration of my left bound, my right bound. So I know my lower limit is going to be 1 negative half, and my upper one is going to be 1/2. And then we're going to integrate area of half of a semicircle, or half a semi, area of a semicircle, which is 1/2 pi r squared. And remember, this is a dx problem. Okay. Now, my radius here, if I look at my semicircle right here, essentially you can call, this would be my radius right here, right? And let's see, if this top portion right here is, we'll say y, right? Then the distance from here to here would be my radius from here to here. So I could say r is simply y. Now, if I notice I have here my formula, this is an r squared, right? So essentially r squared would be y squared. And y squared, in terms of x, remember this is a dx problem. This one right here was a little bit too far. I went just one step too far. It'll just be what, 1 minus 4x squared. So substituting that in back into my definite integral, I have from negative half to half. And then this is 1/2 pi r squared, which is 1 minus 4x squared dx. Okay? And then I'll leave that to you guys, for you guys to solve. You should get the answer of pi over 3 at the very end. And I believe that is choice A. Okay. Moving on to number 26, I have a function defined by f of x equals all that good stuff. And you got a constant of k. So this is natural log of 3x plus 2 to the power of k for some positive constant k. If f prime of 2 equals 3, what's the value of k? Okay, so based on math analysis, I could bring this k in the front using my natural log rules, right? So I can rewrite this as f of x equals k times natural log of my group at 3x plus 2. And they gave me information about f prime at a certain location at 2. So let's go ahead and find f prime first. So f prime of x, k is my constant, just copying down. And then the derivative of natural log of that would be 1 over 3x plus 2 times the derivative of that group, so which would be just 3. Okay. Now this is my derivative, my f prime, and they gave us information about f prime at a certain location too, so I can use that too. That's x equals 2, and you're going to get a value of 3 when you plug it in. Okay. I'm going to use that to solve for k. So I have f prime of 2, which equals to 3, should equal to k times 1 over 3, and x equals to 2, so I'm going to substitute that in for my x. And I'm basically solving this equation, right? So 3 equals, I'm going to move this 3k over here on top. On the bottom you have 6 plus 2, which is 8. And then solving for k, I believe you get k equals to 8. And that is choice letter D. Okay. Okay, number 27. Okay, so this looks like a formula for IRS, infinite Riemann sums, and we never talked about this in class, and I can guarantee it's not going to be on this year in this 45 minutes. But so here's the formula that we never showed about epsilon, right? So if I'm going to start with this is my sum, starting with k equals to 1 all the way to n. And the formula is you're going to plug in, or you're going to have f of, and you're going to substitute x sub k. And then you have a change, or your width of each of your little rectangles, whatever you want to call them, b minus a over n. Excuse me. Okay, so cool. Now in this case here, well this looks like my 3 over n in my problem. And this is going to be this whole thing here, 2 plus 3 over nk. You have a square here. Now let's investigate this part right here, which is not too bad. That means, based on this information here, I have b minus a equals to 3. So the difference between your lower and upper limit is going to be 3. Now if we take a look at, let's investigate what's going on in the very first term, k equals to 1, right? So if k equals 1, okay, I'm going to get my first term, I'm going to call it x1. That's going to be 2 plus 3 plus 3 over n. So this looks like they're starting with 2, and I'm adding a 3n to it. So this must be a right Riemann or right rectangle approximate method, right Riemann sum, whatever you want to call it. So this is a right-hand sum. We can call it a right-hand sum. And the final value, if I started with k going all the way to n, well, my final value, which I'm going to call x sub n, would be 2 plus 3 over n times n, or in this case, 5. Okay, so this is pretty nice. I know it ends at 5. I know b minus a is 3. Well, therefore, a must be 2. Okay, and based on this right here, you notice you have your term here, and you're basically squaring your term, right? We can conclude that f of x is going to be just x squared. So this whole limit, this whole limit of sums, is going to be summarized as the integration from 2 to 5, right? That's a to b, of simply just x squared dx. And this you guys should recognize. We could solve that, right? We can integrate that. Going from 2 to 5, you're going to get a value of 39. And I believe, so 39, good. Yep, it is D. Okay. Okay, and then on for number 28, you got this integration from a to b, f prime of t over f of t dt equals to natural log of f of b. And what is f of a? Okay, so This one I'm going to use a u sub here. Let me copy this problem down here. Okay, so this is number, I'm going to squeeze it in here, number 28. I'm not sure if I said 29, but integration from a to b, you have f prime of t, was it? Okay, on f over t dt. So if we let u equals to, let's say, f of t, conveniently, du is going to be f prime of t dt, which is nice because this is all upstairs right here, right? And so I'm going to convert everything in terms of u, right? So when t equals to, let's start with my lower bound a, well then u is going to be f of a. And when t equals to b, well, u is going to equal to f of b. So now I can convert all of this into terms of u. So I have integration. It was once a, it is now an f of a. So I'm going to put f of a here. And my top would be my f of b. And then I have, oh, well, this is just du over u. Huh, that's nice, right? Because integration of du over u is simply just natural log of absolute value of u. And we're integrating this from f of a, f of b. So remember, I've converted everything in terms of u. I'm not going to go back in terms of t ever again. I already changed everything in terms of u. Don't go back. Well, I'm not going to go back, right? So solving this, I'm going to get a natural log of absolute value of f of b minus natural log of absolute value of f of a. Okay, and the problem told us that this entire problem is equal to, what is it equal to? Natural log, okay, natural log of f of b. And at this point, I don't think we need to worry about the absolute value here. So if you like to rewrite this as natural log of bracket f of b minus natural log, I'm going to use brackets now, f of a equals to natural log bracket of f of b. Well, I can just subtract this from both sides, right? So now I just have, what, negative natural log f of a equal to 0. Or natural log of f of a equals to 0. That means f of a must be 1 in order to take a natural log of it and getting it 0, right? So my answer would be C. Okay, bye for now.